Okay, 4.6 is our last section of chapter 4, and it's the fundamental theorem of algebra. Okay, the fundamental theorem of algebra says if f of x is a polynomial of degree n, remember the degree is the highest exponent in the equation, then the equation f of x equals 0 has exactly n solutions. This is including real, imaginary, and repeated solutions. Okay, we've kind of already known this. We know quadratics have two answers. We know normal equations have one. So this is kind of something we already know. So for example, when it says use the fundamental theorem of algebra to identify the number of solutions. It's only telling us the number, it doesn't tell us the actual answers. This is f of x equals 3x to the fourth minus 7x squared plus 11. The degree of this polynomial is 4. So this should have 4 solutions. Easy, right? Okay. B, f of x equals x cubed plus 3x squared plus 6x plus 10. The highest exponent is x cubed, so this is going to have 3 solutions. Okay, for C, f of x equals 7x cubed minus 2x plus 5x to the 6 minus 11. Okay, be careful on this one. The degree is the highest exponent of any single term. So the highest exponent term is x to the 6th. So this is a degree 6 polynomial, so there are actually 6 solutions to this polynomial. D, f of x equals 3x to the fourth minus x to the fifth plus 2x to the third plus 7x. So the highest degree was 5, so there would be 5 solutions to this polynomial if we were to solve for all the zeros. Okay, for the next example, we're just going to kind of put together all the information we know from this chapter to make a graph for a polynomial function. Okay, we're going to use the rational zero theorem, the end behavior, and then we're going to make a good sketch of the graph. Okay, the first function is f of x equals x cubed minus 6x squared plus 3x plus 10. The first hint is to list all possible rational zeros. So I'm going to look at the last term. Okay, the factors of 10, it could be 1 times 10, it could be 2 times 5, and it could be a positive and negative version of all these answers. Okay, so these are all the possible zeros. I need to find a zero that actually works. So I could plug it into my calculator to find a 0, or I could do synthetic substitution. Okay, I'm going to try synthetic. I normally start with a pretty easy number, so I think I'm just going to start with 1. And you could start with a different number if you feel like 1 looks lucky to you. 3, 10. I'm going to go ahead and mark off my remainder and bring down the 1. Okay, 1 times 1 is 1. Negative 6 plus 1 is negative 5. 1 times negative 5 is negative 5. 3 minus 5 is negative 2. Negative 2. Oh, that's not going to be a 0. Okay, let me rewind. Okay, 1 did not work. What should I try next? I could try 2, or I could try negative 1, or you could go for 10 if you want. I'm going to try 2. Okay, 1 times 2 is 2. Negative 4. Negative 3 minus 8 is negative 5. 2 times negative 5 is negative 10. There's my 0 right there. So one of my zeros is 2. My leftover polynomial is x squared minus 4x minus 5. So what do they want me to do? They want me to factor this completely. Okay, so let me see. I'm going to say f of x equals, my first 0 I found was positive 2, so the factor is x minus 2. And then if I go ahead and factor x squared minus 4x minus 5, that would be x minus 5 and x plus 1. Okay, so that's fully factored. What else does it tell me to do? List all zeros. Those are the x values. So x is 2, 5, and negative 1. I got 3 zeros because the fundamental theorem of algebra told me I was going to get 3 zeros. Okay, now we're going to try to graph this thing using the information. Okay, so since I got 2, 5, and negative 1 is my 0, those are actually my x-intercepts. So my x-intercepts are 2, 0, 5, 0, and negative 1, 0. And I think I'm going to go ahead and add them to the graph. You can either label your points, or you can just make little marks. I'm going to make little marks. Maybe 2, 0, 3, 4, 5, 0, negative 1, 0. Okay, so I already have a little bit of my graph. Okay, I'm going to go up. Now it says, what's my y-intercept? My y-intercept is just the constant at the end. So my y-intercept is 0, 10. So now I know that it's going to be up here somewhere. I'm going to just guess and label it. As long as I label it, it's fine. Okay, last information I'm going to use is my end behavior. Okay, end behavior has to do with the leading term. So let me look back at the leading term. The leading term was the x cubed, so it's odd. If it's odd, it's not going to match on the left and the right. Since it's a positive x cubed, it's going to go up on the right. I'm going to draw it and then I'm going to do it. It's going to go up on the right and it's going to go down on the left. Up on the right, down on the left. So for end behavior, as x approaches negative infinity means on the left. I'm going to say the graph is going to go down. As x approaches positive infinity, that's on the right, the graph is going to go up. And I'm going to graph it. Okay, so on the left, the graph goes down. On the right, the graph goes up. Okay, let me see if I can make this work. Okay, what else do I know? I have the y-intercept, so I know the graph is going to go up, hit the y-intercept. Oh, it's got to go through this x-intercept. And it's going to go back up through here. And that's a pretty good polynomial function. I'm going to try to make it a little curvy, but I included the important information they asked for. Okay, I'm going to go ahead and do the same thing on B and C. You're welcome to work ahead because you've now seen all the steps. Okay, my next polynomial, f of x equals negative x cubed minus 3x squared plus 13x plus 15. Possible zeros. Well, let's look at the 15. Let's see, it could be 1 and 15, 3 times 5. It could be any of these numbers. Just like always, I check the easiest ones first, which you don't have to, but I like to. I'm going to try 1. So this is negative 1. Make sure you put a negative, negative 3, 13, and 15. Let me bring down the negative 1. Let me bring down my remainder. Let's see if this works. 1 times negative 1 is negative 1, negative 3 minus 1, negative 4. 1 times negative 4 is negative 4, that's 9. 1 times, oh, that's not going to work. Let's try again. Okay, I can try any of the other numbers. I'm going to go with 3. Again, you don't have to try the same numbers as me. You might get it faster on your own. Okay, 1 times negative 3, negative 3. So that's negative 6. 3 times negative 6 is negative 18. 13 minus 18, negative 5. Oh, there it is. There's my 0. Okay, so my first 0 is 3. Okay, let me bring down my polynomial. I got negative x squared minus 6x minus 5. Okay, now I'm going to have to factor this more, but I really don't like the negative in the front. It's not an equation I can't divide, but I can take it out. Let me make this positive. Am I ready? I'm going to go ahead and write my polynomial now. Okay, let me finish factoring this. There's a negative in the front. What is that? 5 times 1 is 5. 5 plus 1 is 6. So this must be x plus 5, x plus 1. What am I missing? I'm missing the 0 I found at the beginning. So positive 3 means that the third factor must be x minus 3. The order does not matter as long as you have all the zeros. And I do need the negative in the front because if I multiply it out, it's going to work again. So factored completely. My zeros are negative 5, negative 1, and 3, which means my intercepts are negative 5, negative 1, and 3. Okay, if they're small enough, I'll mark them. If they're too big, I just label them. But you need to do something to show that you actually are plotting them in the correct place. Okay, so negative 5, negative 1, positive 3. Okay, let me go to the next column. Y-intercept. Y-intercept is the constant, so this is 0 and 15, which is quite high, so I'm just going to say 0 up 15 is somewhere up here. Okay, let me just check my end behavior. End behavior, I check the leading coefficient, or the leading term. So the leading term is a negative x cubed. It is odd, so one side's up and one side's down. Since it's negative, it's going to go down on the right and up on the left. Okay, let me fill in the blanks. As x approaches negative infinity means on the left, this is going up. As x approaches positive infinity means on the right, the graph is going down. Okay, let me see if I can make the rest of this graph work with what I have so far. Okay, so I have the y-intercept. So this, I'm going to go here. This must go up through the y-intercept. It has to hit this x-intercept. And let's see, it must go back up here. Okay, so I respected the end behavior, I got the y-intercepts, and I included all the x-intercepts, so this is a decent graph. Let's try one more. Okay, our last function, f of x equals x cubed plus 4x squared minus 3x minus 18. I'm going to list all the zeros again. What's my last number? My last number is negative 18. but I include positives and negatives, so it doesn't really matter. Why is my font so fat? 1 moment. Okay, positive and negative could be 1 times 18, 2, 9, 3, 6. I think that's all of them. You could check your factor sheet if you have trouble thinking of the numbers. Okay, let me set it up. 1, 4, negative 3, negative 18. Should I try 1 again? It keeps not working for me, but one day it might work. Okay, I'm going to try 1 again. 1 times 1 is 1. That's 5. 1 times 5 is 5. Nope, didn't work. Okay. One day it's going to work, though. Okay, should I try 2? Let's try 2. 1 times 2 is 2, 6, 12. Oh, it is going to work. Okay, there's my 0. Okay, I got a 0. What am I trying to do? Fully factor this. I'm going to rewrite this polynomial. X squared plus 6x plus 9. What is the name of this? This is f of x. Okay, so if I do x squared plus 6x plus 9, what is that? 3 times 3? Okay, and then I can't forget my original 0 was positive 2, so the third factor is x minus 2. Okay, so this is my fully factored answer. What are my zeros? My zeros are x equals negative 3, and 2. We don't normally list them twice if they're the same, but the fundamental theorem of algebra says there should be 3 answers even though some of them are repeated answers. So my x-intercepts are negative 3, and 2. Although obviously when I graph them, I will only graph them once. Negative 3, 0, 2, 0. Only 2 x-intercepts. Okay, what's my y-intercept? The constant at the end, so 0, negative 18, which means it's low. So I'll just put it down here and label it so I don't have to make an actual scale. Okay, let's just consider our n behavior. What is this? This is an odd polynomial and it's a positive x cubed, so it's going to go up on the right and it's going to go down on the left in some way. Since it's going, this is saying on the left as x approaches negative infinity, I can tell it's going down. As x approaches positive infinity means on the right side, the graph is going up. Okay, now I need to make it do weird things in the middle. Okay, now here's a little tricky part. I know this has to go down. I know it has to hit here, but it can't hit anywhere else. It can't like pass through. So I'm gonna do my best. I'm gonna make this curve down to here because it has to hit the y-intercept. It has to go up and hit this, but it then has to go straight back down. So make sure you're not hitting any extra x spots. This is negative 3, this is 2. My y-intercept is 0, negative 18. It's going down the left and up on the right. I don't have any extra points I shouldn't have on here.